Okay, so last time we left off with law of sines. The two cases we've already covered are when you know two angles and a side, when you have two angles and a side again, but this time the side is between them. In the last case we were in the middle of is that one, SSA. So whenever you have SSA, that's the only case, including everything we're going to learn with law of cosines, that you have to be careful for no solution, two solution. Every other case is always one solution. Okay, so that's just a reminder of what the law of sines is. It's three fractions. You only use two parts at a time, and you set up a proportion and cross multiply. Okay. So other than that, that's all I really need to remind you about. So let's look at a problem and see what happens. All right, so when you're solving it, remember we set up this table, A, B, and C in one column, alpha, beta, gamma in the other one, but you really should make a sketch. So that way you can tell, is this a problem I should use law of sines for, which will be on the test again, or is this a problem I should use law of cosines for? So now on this test, you're going to have to decide between the two. Let's draw this out. My drawing is not to scale. The only thing that's going to be correct in it is the relationships. A across from alpha, B across from beta, C across from gamma. So A, alpha, B, beta, C, gamma. All right, so now look at the information you've got. You've got two sides, and you've got an angle. Whenever you have two sides and an angle, it could be law of sines or law of cosines. It depends on where the angle is. If the angle was here, if it was the one that was where the two sides meet, this would be law of cosines. We're going to do that next. But this case, it's not the angle that's between the two sides. So it's side, side, angle. So that is the case where we're going to use law of sines, and we got to check if there's a second answer. Okay. So out of the three things I have boxes around, does anybody remember which one you have to try to go for first? Yeah? Beta. You can't do anything with C or gamma. So I'm just going to put a little 1 there just to remind you that's the first thing we're going to find. So we're going to plug in A, alpha, and B into A, alpha, and B. All right. So let's see what we get. So sine of alpha over A equals sine beta over B. And now once I have the proportion, what do I do next? Yep, we're going to cross multiply. When you do that, you're going to end up with this. You'll end up with 8 sine 35 over 6 on one side equals sine beta. But remember the goal is beta, not the sine of beta. So what function do we use to cancel out sine? Yep.
Inverse sine.
Inverse sine. Yep. For 2 or however many week break we've had, you guys are you're doing pretty good. So inverse sine on each side. And now we type all that in. Okay, so let's see what we got. Inverse sine of 8. You could reduce 8 and 6 and make it 4 over 3, but I wouldn't bother just in case you make a mistake. I'm going to do it in degrees. 8 sine 35 over 6. Second, inverse sine, 8 sine 35. Make sure you close the parenthesis. Now when I hit enter, if I get an answer, then that means, assuming I did all my work right, there is a solution. If I get a domain error, then that means there's no solution. Okay. There is a solution, which means I also have to check for a second one. So 49.886. All right, so to check for the second answer, does anybody remember what quadrant the second answer could be in? We just got an answer in the first quadrant. Yeah, second? Yeah, it would have to be in the second because once you get into the third and the fourth quadrant, you're talking about angles between 180 and 360. They're too big. So we got to go to the second quadrant. And does anyone remember what you do with your reference angle to get an answer in quadrant 2?
Don't you do 180 minus the reference angle?
Yep. So if there is a second answer, it's this. 130.114. Now we have to ask if that angle would fit with the one we were given. So does it fit? It does. Right? 130 plus 35 is only 165. So the second answer does work. Right? If the second answer had come out to like 170, well, if you took 170 and added to what was given, it would have been too big. So now we have two answers for beta. So what I'm going to do is call them beta 1 and beta 2. But if beta has two answers, that means everything has two answers. Everything that you have to find. A, B, and alpha were given, so you don't have to do anything with those. But gamma will have two answers, and C will have two answers. So now what we're really doing is two problems at the same time. Okay, I'm going to put boxes in color around everything that's part of a triangle. Let's call it the red triangle. That angle is in the red triangle. That angle is in the red triangle. And that angle is also in the red triangle. Okay. The second triangle, we'll call it the green triangle. That angle is in the green triangle. That's in the green. And that's in the green. So alpha is in both. Okay, it's shared between the two. But beta 1 and gamma 1, those are in the same triangle. Beta 2, gamma 2, those are in the same triangle. Let me do the same thing for the sides. A is in the red, B is in the red, and C1 is in the red. So there should now be 6 red boxes. 3 sides, 3 angles. Green triangle. A is in the green, B is in the green, C2 is in the green. There should now be 6 green boxes. 3 sides, 3 angles. A and B are shared sides. They would be in both triangles if you were actually going to draw these out separate. Okay. All right, so now to get gamma 1, what 2 angles do you think I'm going to add together and subtract from 180? Yep.
35 and 49.886.
Yep. Everything that's in the red boxes. So 35, 49.886, and we're going to subtract that from 180. 6. I don't know what I hit the first time. 95.114. Oh, well, I wanted to write it in black, but I can't. Now I can. All right, what about for gamma 2? What angles am I going to add up and subtract from 180 to get gamma 2? Yep.
35 and 135.
Yeah, everything that's in green. So that's going to give me 165.114. And subtract that from 180. 14.886. So now we have all our angles. Now we just have to find C1 and C2. All right, to find C1, I want to start with a row that's complete. What row should I use that is complete here? Yeah? Yeah, A and alpha, it's in both triangles, the green and the red, and it was given, so we know it's right. So let's use that. All right, so now we're finding C C1. Let's start with A and alpha. Sine 35 over 6 equals, and now if you want to find C1, you use gamma 1. If you want to find C2, you use gamma 2. So let's do sine 95, 114 over C1. So cross multiply, and you're going to get, let's see, 6 sine 95 divided by sine 35. That's your answer for C1. Okay, I'm going to set up C2, and while I'm setting up C2, if someone can just type that in and let me know in a minute what that comes out to. Okay, so now to find C2, still going to use the first row because that was given. So sine 35 over 6. But what is going to go on the right side this time? Yeah.
The sine of 14.886.
Over C2. Yep. So sine 14.886 over C2. And we cross multiply just like we did on the left. So it's 6 sine 14.886 over sine 35. 14.886 over sine 35. That's your answer for C2. Okay. Does anybody have what C1 comes out to? Yeah, Blake?
10.419.
10.419. Right. And now C2, we're pretty much typing in the same calculation except change 95,114 to 14,886. What does C2 come out to? Blake?
2.687.
2.687, thank you. Okay. And that's it. That's the worst case for law of sines that you can have. That's a two-solution case. So it's not that it's really harder, it's longer. You just have to do exactly the same calculations. Double. Okay. So any questions on that? And side angle, that is the only time it can ever happen. Out of all 5 cases we're going to learn. There's these 3, SAS and SSS. That's the only one that it happens. Okay, so any questions on it? All right, so let's try. Sometimes I show you how you can actually physically sketch the two-solution case. But I'm not really worried about physically sketching it. That's fine. But you can. All right. So I can tell that this is law of sines just by looking at the table. Anybody remember how you can just look at the table? You really don't. You don't need the sketch if you don't technically want to make it. Yeah.
Isn't it if you have like a full line that's empty?
Yeah. Wait, can you say it again?
Like a full line that's empty, like meaning like both parties say the same thing doesn't have a designated number. So like there's B and beta that don't have anything.
All right, the fact that there's an empty row, that tells me something else, but it doesn't necessarily, does that tell you to always use law of sines? Well, there might be cases where you don't have an empty row, but you still use law of sines. Yeah.
You have a full column.
Well, we don't have a full column here.
Can like find by like doing subtraction. Like no, I mean full row.
Full row. Okay.
Yeah, there we go.
So yes, we do have a full row, horizontal. So that tells you that it's law of sines. And the fact that there's an empty row with no way to get anything in it right away tells me that it's the worst case. I have to check for the two answers. All right. So let's set it up. What do I have to try to find first?
Alpha.
Yeah, alpha. So we're going to have sine of alpha over 2 equals sine gamma over 1. Now really, we don't even need to, actually let's fill in 50 for gamma, sorry. Because 50 is just divided by 1, really when you cross multiply, all you're going to end up with is sine alpha equals 2 sine 50. So that's all that happens. Sine alpha is 2 sine 50. And then Kaya, to get rid of sine, what do we do?
Inverse.
Yep, inverse sine. So it's the inverse sine of 2 sine 50. Now, anytime you take the inverse sine of a number, you're basically finding an angle at a certain height on the sine graph. What's the highest and lowest that the sine graph goes? Yep. 1 to -1. So what we're trying to do is we're looking for this height on the sine graph, and then when we take the inverse sine of that y value, we're getting the x value, which is the angle. So let's see what happens when, let's look at 2 sine 50. 2 sine 50. That's at a height of 1.53. So what's going to happen when I try to find the angle where the graph hits a height of 1.53? It's not going to work. The graph never hits a height of 1.53. It only hits a height of -1 to 1. So when you type that in, it's going to tell you there's a domain error, right? Which means that there is no solution for alpha. Well, if there's no solution for alpha, then there's no solution for everything. Because if you can't find alpha, then now you can't add together alpha and gamma to get beta and subtract from 180. And if there's no solution for beta, you can't find the side across from it either. So that's the quickest case, where there's no solution at all. What that basically means is if you were to try to actually draw this to scale, like maybe draw a triangle, one side is 2 inches, 1 inches, and you use like a protractor and make gamma 50, your sides wouldn't connect. You could have a triangle that maybe looks something like this. They wouldn't meet. And you wouldn't be able to change the length of this side and the other side because those lengths were given to you. You would be able to change B. You could make this as long or as short as you want. But making it longer or shorter, it's not going to help you connect to that third side. And you can't change this because that angle is given to you as 50. But you could take this and you could turn it. So you could put it over here, you could put it out there, you could put it there. But all you can do is turn that side, but you can't make it longer. So there's no way to make these sides connect. That's basically what would happen. Okay. Any questions on that case? Okay. The last thing we'll look at before we do law of cosines is a word problem. Let's do, I have 2 of them. We're just going to do one of them. Let's do the second one. All right, so this situation, just to kind of set up what's happening here, is there's a boat out in the ocean somewhere, and the boat, their GPS isn't working, radio isn't working, but they sent up like a flare. So Coast Guard station saw it, and they know that there's a boat out there that needs help. They saw the flare. It's at night, So the flare was easy to see, but it's cloudy, so the boat can't really see stars to kind of figure out where they are. And their engines don't work. They're in rough shape. So, but they have a light on top of their boat, really powerful light. And each Coast Guard station can see that light on top of the boat. All right? And they know they're in trouble because the boat sent up a flare. So, the trick is they're going to be able to figure out where the boat is because two different Coast Guard stations are going to be able to see the light on top of the boat. If only one station could see it, all that station could say is the boat is that way. They could just point and say it's that way. I don't know if it's 20 miles that way, 25 miles, 30 miles. But what's going to help narrow it down is another station is going to be able to see the same light from a different spot. And then two people seeing the same thing, you can triangulate where the boat is. So that's basically what we're going to do. All right. So the two Coast Guard stations are 120 miles apart. Okay, we're calling them Zulu and X-ray. It does matter which one is west and east of the other. So for our purposes on the board, west is going to be left and right is going to be east. So again, the ship sends out an SOS. Maybe they use that light on top of their boat. And one of the Coast Guard stations, Zulu, sees that light on top of the boat, and they can tell me the direction it's coming from. Right? It's coming from a direction 40 degrees east of north. 40 degrees east of north from their perspective. Okay? So that's where they see it from. It's 40 degrees east of north. Now, if you're somewhere else, you may be pointing in a different direction because you're 100 miles away and you see the same thing, but it's from your perspective, it's coming from a different spot. So then the call to the other station, or the light that they see, is coming in 30 degrees west of north. So what we're going to figure out is how far is each Coast Guard station from the boat. Now this also assumes the boat isn't drifting, because if the boat was in a current, it would be maybe moving the whole time. So the distance between, would change. But we'll assume the boat is anchored, so it's not really moving. And knowing the distance may impact which Coast Guard station would send help to the boat. I mean, there's other factors too that would affect that. Like if the current is pushing the boat towards one station, it might be farther from that station now, but if it's going to take like a helicopter 2 hours to get to the boat, that ship might move a lot in 2 hours. Maybe it'll move closer to the other Coast Guard station. So they'd have to factor in the currents and things like that. But we'll just try to keep it simple. All right, so we got a lot of different information here. What do you think we should probably do to make that easier to think about, rather than looking at all that information in words? Yeah. Yeah, we're going to draw it, and hopefully we're going to end up with a triangle as a shape somewhere. All right. So out here, this is going to be land, and we're going to have two Coast Guard stations on land. And then out above that, this is going to be water. We're going to have our boat out there. Okay, so one thing we do know is how far apart the Coast Guard stations are. How far apart are they? 120 miles, and I'm just going to call them Z and X. Z is to the left of X. So this is Z, X, 120 miles. How do they know they're 120 miles apart? Well, it's just like, how do you know the distance from here to Boston is like 50 miles or something? You can just look at a map and you can see. All right, so now, both of the directions are from north. Okay, one of them is 40 degrees east of north, the other one is west of north. So from each Coast Guard station, let's put a line that represents north. Okay, I'm going to make that a dotted line. It doesn't have to be dotted. Okay, so north is going to be up and down, and I'm just going to put another one over here. So now it says the call from, all right, Coast Guard Station Z is coming in 40 degrees east of north. Right? So let's draw a line that represents like where the beam of light is coming from on the boat. Okay, let's say it's coming from right there. Now that direction, if this is east and that's north, that beam of light is 40 degrees to the east of north. Okay, so it's like to the right of it. All right, and now this Coast Guard station is going to see exactly the same light, but it's going to see it from a direction 30 degrees west of north. Right? So west is over here. So west is to the left. So 30 degrees west of north. Okay. And what we want to figure out is the lengths of the sides that we don't know in that triangle. Okay. So what I want to do now is just look at this triangle. And you can leave it right there. I'm just going to move it down so I can just focus on looking at that. Okay, bottom side is 120. You know that. How about that angle right there? How much is that?
50.
Yeah, it's 50 because between north and east, that's a 90. So this angle is 50. And how about that angle right there? Yeah, 60. So now, all you have is a angle side, angle joint. Okay. In order to solve it, you have to know an angle and a side across from it. That's like knowing a full row. Well, I don't see in that picture an angle that I know and the side across from it. But is there anything I can find that would give me that? Yeah?
You find the other angle.
I can find the third angle, even though it wasn't given to me. I need it. And then knowing this and this is like knowing a full row. Okay. So what would that third angle be? Yeah. Yep. This is 70 degrees. Let's call this side X and Y. So when you set up your proportion, sine of an angle, divide by what's across from it, equals sine of an angle, divide by what's across from it. And use what's circled both times. Sine of an angle, divide by what's across from it. And if I'm going to find X, what would be my fraction on the other side? Yeah, Madison.
Sine of 60 over x.
Yeah. Sine of 60 over x. And now just solve for x. So it's going to be 120 sine 60. Let's see what that comes out to. 120 sine 60 divided by sine 70. So the distance on the left side of the triangle, whatever that is 110.6 miles. And that was the distance from Zulu to the boat. The left side. So now let's set it up one more time to find what? So use the left side over, sine 70 over 120, and then we'll just change the angle, and that'll give us y.
I'm confused how you got the 50 and 60 out as the angles because it said that it was 40 and 30 in the.
So we used 50 and 60 for the angles. How did we get those instead of using the 40 and the 30? Yeah, okay.
Complementary.
Yeah, they have to be complementary because this is a 90. And you're interested in the angle in the triangle, not the one on the outside of it.
Okay.
All right. So we've got sine 70 over 120, sine 50 over y. Okay, we'll see what we get. All right, so we've got 120 sine 50 divided by sine 70. So given that the boat's not moving at this moment, it's 97.8 miles to the other Coast Guard station. Any questions on that? Okay, so that's law of science. Right, so we looked at the two solution case, the no solution case, and then a word problem. All right, so that's the homework. Let me just double check. All right. You don't have to do 18. Okay, so there are some in there that are no solution. So you're going to start a couple of those right away and you're not going to be able to solve them. Okay, and 19 is a word problem, exactly like what we just did, except it's about a tornado instead of a boat. And two different observers see the tornado. Okay, so law of science. All right, so kind of the last part to this is law of cosines. So when we did law of sines, LOS, we solved these three types of problems. Side angle angle, angle side angle, side side angle. Which one of the three there is the one that we got to check for the two solution and all that stuff? Blake?
Side side.
Yep. So that's the one where you got to check for the second answer. Law of cosines is going to allow us to solve two other types of triangles, and I've already mentioned them. Side angle side. That's where you know two sides and the angle. And side side side. Now, if you're wondering, why can't I use law of sines on side side side? Well, if you try, what's going to happen is that you know this, you know that, and you know that. You don't have a full row. So when you try to set it up, you always have to pick two rows when you use law of sines. So if you try the first two rows, you're missing two things. No, it's no good. If you try the second and the third row, you're still missing two things. No. If you try the first and the third row, you're still missing two things. There's no way you can pick two rows and only be missing one thing. Okay. So that's where law of cosines comes in. We're going to hold off on the proof of the law of cosines. And I'm going to show you what the formula is. If we had a full lesson on it, it's not really that hard to show where it comes from. Does anybody recognize kind of something in that formula? Yeah?
C squared equals A squared plus B squared.
Yeah, what's that?
And then
Yeah, and the proof, if we were going to go through it, it involves a right triangle and using Pythagorean theorem. So it's kind of like Pythagorean theorem, but there's this adjustment on the end. This minus 2ab cosine gamma. So you can actually still use this formula even on a right triangle. It's just when you're dealing with a right triangle, well, watch what happens. If I was dealing with a right angle, and let's say gamma was the right angle, across from side C, that means gamma would be how big if it's a right angle? Okay.
So what was that?
How big would gamma be if it's a right angle?
45.
What's a right angle? How big is a right angle? 90, yeah. So if gamma was a right angle, it would be 90 degrees. So if you plug 90 into that formula, and you were trying to use it on a right triangle, watch what would happen. Cosine of 90 is 0. What's 0 times 2 times a times b? It's 0. It doesn't matter how long a and b are. So if you try using this formula on a right triangle, what happens is you're really just subtracting 0, and you don't need that last part. That's why all you have is the Pythagorean theorem. Well, when that angle's not 90, that part is not 0, and then we have to use it. Now, there's 3 different versions of the law of cosines, and they're all arranged very similar. Does anybody have a guess what the second one would look like if it kind of follows the same pattern as the first one? Rob?
B squared equals a squared plus c squared.
Yep.
Minus 2 AC.
Yep.
Cosine of no idea what the last part would be.
What would the last
Cosine
one?
beta.
Cosine beta, yes. So the way I remember it is it's one side squared equals the sum of the other two squared minus twice the product of the other two you just wrote times the cosine of the angle that's across from the side you started with. It's kind of important to understand the general idea, especially if you just have a word problem and your sides aren't labeled A, B, and C. That's going to mix you all up if you're like, wait, the sides are like X, Y, and Z. They're not A, B, and C. So how do I do it? If you just understand the idea, then it doesn't matter what you label them. And how about the last version? Yeah.
A squared equals b squared plus c squared minus 2bc cosine alpha.
Yep. And you plug into whichever formula you have enough information to use. You never want to have two unknowns in the equation. You only want to have one. So the two types we're going to do are side angle side and side side side. One of them, you have freedom to pick any one of these equations to use. The other one, you have to find something first. Okay? And you'll see when we solve it, it's pretty obvious. All right, let's take a look at this one. Now we could make a sketch, but without even making a sketch, looking just at that table, how do you know it's not law of sines? Yeah, Allison. There isn't a full row. So no matter which two rows you try to pick, if you were going to use law of sines, you're always going to have two things you don't know. You can't do that. So if you were to sketch this out, this is a side angle side problem, SAS. Now, every version of the formula has every side in it. You will find an A, a B, and a C in every formula. So we're already missing C, which means we're missing the side So out of these, there's only one thing you can use, one version you can use. If you call this one the first one, the second one, and the third one. Which version do I have to use? And if I don't, I'm going to be missing the angle too. Yep.
What's the first one?
Yeah, I've got to use the first one because I've got the A, the B, the A, the B, and the gamma. Yep. If you use the other ones, you're going to be missing other stuff. So let's use the first one. Now, this is more like PEMDAS. You're not really getting the variable by itself. I mean, at the end, you got to take a square root, but the variable is pretty much on the left. You just have to do a bunch of arithmetic on the right. So we've got, and I'm going to do a little bit of it as I go. A squared, B squared, minus 2AB. So let's do that out. 2 times 4 is how much? 8 times 7. 56. Cosine 42. Now, there's no parentheses, so it might be kind of like, well, how do I know what to do first? You follow PEMDAS, order of operations. So, according to PEMDAS, what would I do first there? Yep, cosine of 42, and then what are you going to multiply it by? Yeah, so let's do that first. So I've got 56 cosine 42. So that's going to give me minus 41.616. Minus, what did I say? 41.616. Now we just do addition and subtraction in the order you see it from left to right. Okay, so we could just type that all in. 16 plus 49 minus 41.616. That gives me 23.384. Now, is that C? What's the last thing I have to do? Yep, Ross. Take what? Yep, square root it. And again, this is technically approximate because we rounded it off. So let's take the square root of 23.384, and that means C is 4.835. As long as I typed everything in right, I hope I did. I think I did. So, any questions on that? Now that you have all the sides, you can use any version of the formula you want. Whenever you have all the sides, you can use anything. So now we can do either alpha or beta. Kaylee, which one do you want to try to find next?
Beta.
Beta. Okay. So let's find beta. Which means I'm going to be using version 2. B squared equals A squared plus C squared. Let me just see if I can go like this so I can see the sides at the same time. Alright, so B squared equals. Now, to get C squared, don't take 4.835 and square it. Just look at the line above it. C squared. It's already right there. 23.384. All right, so B squared equals A squared plus C squared, or C squared plus A squared. It doesn't matter. Minus 2 times, let's go back to the formula, A times C. 2 times A times C. So 2 times A is going to give me 8. I need 8 times 4.385. That gives me 35.08. cosine beta. So b squared, c squared, a squared, 2ac cosine beta. All right. Now, this one's a little different because the variable's not by itself. So this is now more like solving an equation. It's not really PEMDAS. We're going to get the variable by itself and combine like terms if we can first. Are there any like terms there that I can add together? Yeah, okay.
23.384 plus 1 plus 16.
Yeah. 23 and 16, we can add those up, and we get 39.384. All right. Now, what would I do next? This is a part where sometimes people make a mistake. Yeah?
We're going to subtract 39.384.
Yes. This equation is basically just like this. You can't do 39 minus 35 because they're not like terms. The 35 is multiplied by a variable that you don't know. So you have to bring the 39 to the other side, and then you can divide by the 35, negative 35, and that will get x by it, or the variable by itself. Right, so it's minus 39,384. 39,384. So 49 minus 39.384 gives me 9.616. Okay, now I just told you the next step. You can divide by the negative 35, and when you divide it, I would just leave it. Don't even do it out. So I have 9.616. Now, I want to get rid of cosine at the same time. So normally I would write cosine beta. But how would I get rid of cosine beta just so I don't have to rewrite the whole equation up another time? Yep.
Inverse cosine.
Inverse cosine. So what we did at that step is we divided by negative 35, and then we did inverse cosine. And that's going to be our answer. So let's see what we get. Now, if you look at that, and what's in right here is bigger than 1, don't even type it in, because it's not going to work. So if the number in the top has a bigger absolute value than the one in the bottom, it's not going to work. But when you divide 9 by negative 35, you're going to get a decimal less between negative 1 and 1. So that's good. So let's see what we got. 9.616 divided by negative 35. Okay, so we get 105.909. And now to get alpha, I'm just going to add gamma and beta and subtract from 180. Okay. You could find alpha the same way, but I'm just going to add up the 2 and subtract from 180. 180 minus 105.909 minus 42. So 32.091. Okay, so it looks like the smallest side is with the smallest angle. The biggest side is with the biggest angle. And if you add any two sides together, they should be bigger than the third. Looks reasonable. And that's law of cosines. So the side angle side type involves both things that can happen in law of cosines. This is one type, where you're solving for a side. This is the other type, where you're solving for an angle. those are the only two paths that you can ever take in law of cosines. Solve for side, solve for angle. When you do a side-side-side problem, you're never going to have to solve for a side. You're just solving for an angle. Now, at a minimum, in this problem, how many times do you have to do law of cosines to be able to solve the whole thing? Okay? You've got to do it twice. Now, you could do it 3 times, and the benefit to doing it 3 times is that you would be finding alpha, beta, and gamma totally separate. If you do it twice, and you rely on what you found to get the third angle, what could happen? Yeah, good.
By using something you found, if you made a mistake, it's only going to grow.
Yeah.
Further,
Yep.
further.
So if you got something wrong, it's going to mess up other things. Now, can anybody think of a case where I would only have to do law of cosines once to solve this side-side-side problem? Yeah?
What if 2 of the sides are the same?
Yes. If you had an isosceles triangle, you only have to do law of cosines 1 time. Because 2 of the sides are the same, which means 2 of the angles are going to be the same. And you can figure out the third one from there. All right, so let's find gamma. I don't think we've used, I don't know if we used the one for finding gamma. We did beta, so maybe we'll do alpha and gamma this time. So Kathleen, if I want to find gamma, how does my formula start for that?
C squared
Right. C squared, yep.
plus 9 squared plus 7 squared
7 squared, yep.
minus 2 times 9 times 7
So 2, 9, 7, yep.
goes 9.
Gamma. Okay. So let's do that out. We already squared A and B as we went. So we can add, I mean, technically if you're following PEMDAS, you should do 2 times 9 times 7 first. But adding 81 and 49 is a totally separate part of the problem, so it's not going to mess anything up. So 81 and 49 gives me 130 minus 18 times 7. 126. Natalie, what's my next step?
To bring the 132 to the side.
Yep, and how do you bring it over? It's gone. It's gone. 25 minus 130 gives me negative 105. And the last 2 steps, we can do them at the same time. What would I do first? Oh, Justin.
I'm not sure.
Right. Well, what do we have to get away from the gamma? What are the 2 things that we don't want next to gamma? Do you see what's next to gamma that's preventing it from being by itself? Here's gamma. What's next to it that we don't want?
Negative 126 cosine.
Yep. So the negative 126, one thing. The cosine, separate thing. So we want to get rid of both of those. Which one do I get rid of first? How about Nate?
The negative 126.
Yep. And how do you do it?
Divided.
Yep. So we're going to divide. That's going to cancel the negatives on the other side. And now I would have cosine gamma. And how do we get rid of cosine? Emma? Inverse cosine. Okay. So second inverse cosine, 105 over 126. 33.557. Now, if you look at that, technically you have a row that's complete. So you could try to do law of sines on this, but watch what happens if you do. So you got A, alpha, B, beta, and then C, gamma. So this problem started out as side, side, side. That's what we were given. Side, side, side. Now, with this piece of information right here, it's also side, angle, side. It's like the first type we did. So you could do it like that. That would still be law of cosines. Or you could think of it as side, side, angle. You have a side, and then an angle that's not between them. If you think of it as side, side, angle, which law is that? Yep. Law of sines. But remember what we said about side, side, angle? That's the case where now you've got to deal with the one solution, two solution, no solution. So I would not try to finish this problem with law of sines. Just do law of cosines one more time to finish it up. I'm not saying it wouldn't work, but you'd have to be very careful about the two solutions, where the law of cosines will automatically just give you the right answer. Okay. So is there any question how you do law of cosines one more time here? It'd be exactly the same steps. Just find alpha or beta, and then subtract from 180 once you get the 2. All right. So we have the area of a triangle and then a word problem. All right. So something else that's in this section, and it's kind of related to law of cosines, is finding the area of a triangle. So you might be looking at it like, wait, area of a triangle? Well, you're probably familiar with 1/2 base times height. Okay, you can definitely use that formula to find the area of a triangle. But sometimes we don't know the base or the height. Okay, so let's look at the picture that I have here. Okay, I've labeled some things in that triangle. I've labeled B is the base, H is the height, it's that dotted line. And then 2 of the sides, A and C. Right, so what I want to do is come up with a formula if I didn't know one of those two things. Let's do it for the height. So let's say you didn't know that. Okay. So maybe in a triangle they gave you something like this. This side is 2, this side is 6, this angle is 100 degrees. Well, that 2 isn't really the height. That's the height, straight down. Okay. So in that problem, you don't know the height. If they gave me this and this, what trig function could I use to find the height of this triangle? You only need to use the things that are circled to find the height of that triangle. Yeah?
Side, side, angle.
So what trig function would I use? They use sine, cosine, or tangent? Because this is a right triangle right here, right? We don't even need to worry about law of sines or law of cosines to find the height of that red triangle. Yeah.
Sine.
Yeah, because what's the definition of sine?
It's opposite over.
Yes. Sine is opposite over hypotenuse. So the sine of your angle, don't confuse h with hypotenuse. I used h for height. That's a bad idea, but oh well. So the sine of my angle equals h over c. Now to get h by itself, just multiply both sides by c. Times c, times c. And there you go. There's a formula for the height. So what I'm going to do is I'm going to take the formula that I just came up with for the height, I'm going to fill it in right there, and that's going to be my new formula for the area of a triangle. So it just uses trigonometry to calculate the height when you're not given it. So the area equals 1/2. You still have the base. They got to give you that. But instead of the height, put c sine alpha, because that's your height. And that's actually the first one I was just going to write below. 1/2 BC sine alpha. Now, you can do this with any two sides. You could have B and C, A and C, or A and B. Doesn't matter which two. But look at the first one. A, B, C, alpha, beta, gamma. Look at B and C. And look at alpha. Where is alpha? Where is its position compared to B and C? Yeah?
It's where B and C meet.
It's right where B and C meet. What's the angle where A and C meet?
Beta.
Beta. And the angle where A and B meet? Gamma. So I'm writing the same formula 3 times. I'm just using different sides. But the idea is if you want to find the area of a triangle and you don't know the height, but you know 2 of the sides and the angle between them, you can use this formula. And this is the general idea. The area of a triangle is half the product of 2 sides times the sine of the angle where they meet. Half the product of the 2 sides times the sine of the angle that's between them. Okay, let's try an example. So using that idea, half the product of the 2 sides times the sine of the angle between them, anyone think they can set up my equation to find the area of that triangle? Because the sides aren't labeled A, B, and C. So you're not going to be able to say, oh, well, I'm just going to use a certain version of the formula. You really have to understand the idea of the formula, not which version of it you're using. Chris?
1/2 3 times 12 and sine 105.
Yeah, that's it. So what you're really doing right here, even though you're not thinking about it, is you're making a right triangle. The sine 105 times the 3 is actually giving you the height. This part right here that I just circled, that's the height of your triangle. And then you're doing 1/2 the base times the height. That's really what you're doing. So we've got 3 times 12 is 36. Half of 36 is 18. And now we just type it in. 18. This calculator is weird. Let me do the sine of 105 first, and then times 18. Okay. So the area is 17.387. Now, because it's an area, just make sure you put square units. If I knew it was inches, I would have put square inches. Okay. But that's one way you can find the area of a triangle. Any question on that? Okay. So we're going to do one more finding the area of a triangle, and that's where we'll stop for today. Okay, so this formula is called Heron's formula. I'll let you copy it down, and then we'll do one example, and that'll be it. Now, this is kind of where the connection would come into law of cosines. Heron's formula is used when you're trying to find the area of a side, side, side triangle, where you know all 3 sides. Well, if you know all 3 sides, you could find one of the angles using the law of cosines. And then, once you have that angle, you could go back and use the formula we have right here. That's one way you could do it. So technically, you don't even need Heron's formula. Just use law of cosines, find an angle, and use the formula I already showed you. But if you want to avoid having to do the law of cosines, this gives you the area of a triangle without ever finding an angle. Okay. The proof of Heron's formula is a little more complicated than the one I just did, so we're not going to go over the proof. But A, B, and C are the sides. S, that's a letter we haven't seen before. S is the semi-perimeter. All that semi-perimeter means is it's the perimeter cut in half. So it's a very, very easy formula to use. You just plug in A, B, and C. You have to find the semi-perimeter yourself. And then you do all the calculation. S minus A, S minus B, S minus C. Doesn't matter which side is A, B, and C, because you've got to do S minus every side. Okay, let's try one of those. Okay, what if you find the perimeter and then take half of it? That's the semi-perimeter. What's my semi-perimeter here? Yep, 10.5. So the area is S times S minus every side. So let's just kind of do it as we go. What's 10.5 minus 9? 10.5 minus 7. 10.5 minus 5. 5.5. You just type that in, and that's the answer. It's more interesting, why does this formula even work, which isn't really something we're going to talk about, but the proof is, it's in your book. So the square root of 10.5 times 1.5 times 3.5 times 5.5. So the area of the triangle, without using law of cosines, we totally avoided it, is 17.41 square units. If you don't like Heron's formula, just do law of cosines and find an angle, but I think that takes longer. So the only thing we didn't really finish was a word problem, which we can practice one tomorrow when we go over the homework. All right, so 1, 2, 5, 6. And then from that part, just do 17, and 19. So you got like 8 or so problems here. I think there was like 5 or 6 on the other one, so it's probably about 13 or 14 questions altogether. Okay, we'll take a look at that tomorrow.